Now, in this lecture, we will see how to write the program for the subtraction. Now, what is subtraction? Now, if I try to subtract a lower value from the higher value, I'll get the answer in positive. Now, if I subtract a higher value from the lower value, I'll get the negative answer. Now, in a microprocessor, how it subtracts, then how to write the program for that. Now, we will see here. Now, for this first one, 5, if I'm subtracting from 3, if I'm subtracting from the 5, then how to, 5 means what? How to take 0503H. Now, in a microprocessor, we have to write in a 8-bit. So, 8-bit binary value, I can represent with a 2 digits in a hexadecimal. So, I am representing like this. So, 5, I can write it as a 05, 3, I can write it as a 03. Now, for that, if I write the equivalent binary value for 0, all zeros, for 5, 0, 1, 0, 1. This is the binary equivalent value for this hexadecimal. Now, similarly, if I write the binary equivalent value for the 3, then for zeros, all zeros, 3, how can I write? 0, 0, 1, 1. If I subtract, then how to subtract? 1 minus 1, if I subtract, then I'll get 0. And 0, from 1, I can't subtract from the 0. That's why I need to get the borrow. Now, if I'm taking borrow here, then I will take borrow 10, and here it will become what? 0. So, from 1, 0, if I am subtracting, 1 is subtracted from the 1, 0 means what is the answer? 1. So, now here you try 1, 0 is nothing but what? 1, 0 is in the binary. If you write the equivalent form of decimal, it is nothing but what? 2. So, now if you are subtracting 1 from the 1, 0, then you will get 1 value. So now here 1, 0, if I'm subtracting 1, then I'll get 1 here. And from the 0, this 0 will get 0, 0, 0. So remaining all are also 0. Now if I write the equivalent hexadecimal for this one, then for this 4 zeros, I can write it as a 0. And this is nothing but what? 2H. And no borrow generated here. So no borrow generated means what? Answer is in the positive. So this is the answer when you are subtracting the lower value from the higher value. If you are trying to subtract the higher value from the lower value, then what happens? First 3, how can I write? All zeros, 0, 0, 1, 1. And 5, 0, 5, how can we write? 0, 0, all zeros, and 0, 1, 0, 1. This is the 5. Now, if you are subtracting, then 1 minus 1 is what? 0. So, if you are subtracting 0 from 1, then you will get 1. So, here you have to subtract the 1 from the 0. But here you can't subtract. That's why you need to get the borrow. But if you see, all are zeros only. So you can't get the borrow from here. So borrow will generate here, and here it is 1, 0, and it become 1, and it is giving borrow to here. That's why it become 1, and it is giving borrow to here. That's why it become 1, and again it is giving borrow here. That's why it is 1, and again it is giving borrow, and here it is giving borrow. It's good. Now from 1, 0, if I'm subtracting 1, so here I'll get 1. Now 1 minus 0, 1. 1 minus 0, 1. So remaining all are 1s only. Now if you see the answer here, this is in the form of 2's complement. To get the answer, we need to do the 2's complement. Now borrow is generated. Borrow means nothing but what? Carry flag set. Carry flag is set now. And answer is in the 2's complement. So that's why you need to do that. Now this answer is in the accumulator. So you have to do the 2's complement of this one. Then you will get the original answer. Then how to get the 2's complement? First to take the 1's complement of this. Then you will get what? 0, 0, 0, 0, 0, 0, 1. And add 1 to this. Then you will get the 2's complement by adding 1. So 0. Carry generated the carry, and this is 1, and the remaining all are zeros. Now for this, if you write the hexadecimal for this 4 zeros, it is 0, and 0, 0, 1, 0 is nothing but what? 2H. Now here the answer is 2, but carry is generated. Carry generated means what? Answer is negative. So for this, we need to write the program. So if whatever the value you will give, you can give. So for that, what it has to give the, if you are subtracting the lower value from the higher value, it's supposed to give the positive value. Means what? Carry should not generate. Carry value should be 0, and answer should display. And if you are subtracting the higher value from the lower value, then carry will generate. Means what? Carry should be display. Carry we have to display, and answer will be, we have to give the answer in the 2's complement. So we need to do the 2's complement. For that, what we need, how to write the program initially. Now I'll store the data in 6500. Why I have to store the data in 65 means, now in the lab, the microprocessor manufactured by the Anshuman Electronics. Now, Anshuman Electronics, while manufacturing, they have given the RAM locations only from the 6000 to 6FFF. Now, these are the locations provided for us to write the program and to store the data. Now, in this, I'm taking the 6500 for storing the data. Now, here I have stored the first value, and here I have stored the second value. And the next consecutive memory location I'm taking to store the result difference. And the next location I'm storing to I'm using to store the carry value or borrow value. Now here we should not say borrow, so it is we have to consider borrow and carry both. We have to display with the carry flag only. So there is only one flag, that is a carry flag. With that only we have to show the carry and borrow. Now further to how to write the program initially, to for the carry, I have to take one register. Now in this case, I am taking the register C and that I am initializing with the 0 zeros. If carry is not generated, I have to move the same this 0 value. If carry is generated, I have to increment this register. How to do that, I will explain later. Now this C, I cleared the C register value with 0 and I'm using this C for what purpose? For the carry, storing the carry purpose. Next one is what? Now memory locations, I have stored the data and I wanted to store the result also. So for this, what I need to initialize the HL register pair with this location, so that to HL point to this location. LXI H comma 6500 means what? HL pair is pointing to this location. Now first location value in a microprocessor, all arithmetic and logical operations we have to perform with only with the accumulator. That's why the first value I need to move into the accumulator. So what is the instruction for that? Move A comma M. M is nothing but what? This location. This location HL is pointing to this location and M is nothing but what? HL pair. Instead of using the HL pair, we have to use the microprocessor 8085. It is designed like that. Wherever M is we are writing, that is nothing but what? HL pair, where it is pointing in that location, whatever the data is there, that data we are moving into the accumulator in this case. Now again, what HL pair is supposed to indicate the next location. For that, what I need to do? I need to increment the HL pair. How to increment? INX H. X indicates what? Pair. So INX H means what? HL pair, now it is incremented by 1 and it is pointing to this location. Now in this location 3 is there, that I have to subtract from the accumulator. So sub M I have to use. Sub M means what? HL pair is pointing to this location. Now in this location 03 is there. That 03 I am subtracting from the accumulator content. Sub M means what? M I am subtracting from the A and result is again stored in the A. Result is nothing but what? Difference is stored in the A. Now here, after the subtraction, I need to check. Now after the subtraction, now here, what I'm saying, if carry is not generated means what? Positive value I'm saying. If the carry is generated means what? I have to take the 2's complement for the answer. So for that, I need to test the carry here. How to test the carry? I have JNC and JC instructions are there. Now, if there is no carry means what? No need to do anything. Simply you have to store the result. Now, this result I have to store and this carry also I have to store. So that's why I have taken the JNC, no carry. If carry is not generated, what I need to do? Simply I have to store the result. For that, what? Where I need to store the result? 6502. For that, what I need to do? I need to increment the HL pair. Now, HL pair is pointing to this location. Now, HL pair should point to this location. That's why first I have to increment the HL pair. Thereby, what? HL pair is pointing to this location. Now, I have to store the result. Where the result is? Result is in the accumulator. Now, move M comma A means what? Accumulator content I am moving into the memory location which is pointed by the HL pair. So now I have moved the accumulator content. Now if I have taken the positive value, no carry means what? This result as it is, I have to move. And also I have to store the carry. Carry for which register I am using? C register I am using. For that what? One more time I have to increment the HL pair so that it has to indicate the next location. Now increment HL pair. Thereby what? HL pair is indicate it is pointing to this location. Now here I have to store the carry flag. How to store the carry flag? Carry flag is indicated by the carry is indicated by the this register. So move M comma C. move M comma C. Now after that what? Program is ends. Program ends here. Now halt, HLT. So this is for the, now if the subtracting lower value from the higher value. If you are trying to subtract the higher value from the lower value, now up to this is same. Now here what happens? Carry generates. So now in this case you have set here carry is generated. So borrow set, right? Borrow set means what? Carry generated. If carry generated, what you need to do first? You have to save the carry. How to save the carry? INR C means what? This C register I am incrementing by 1, thereby I'm saving the carry in this register. Now after that what I need to do? I have to do the 2's complement of the result. Now where the result is in the accumulator. For that I need to do the 2's complement. So for that what I have to do? First 1's complement, then adding 1. So 1's complement means what? Complementing the accumulator. What is the instruction for that? CMA. CMA is nothing but what? Complement accumulator. And after that you no need to give anything. This is the implicit addressing mode. So CMA means what? Automatically accumulator will be complemented. And after that, what we need to do? We have to add 1 to this accumulator. Then how to do that? ADI 01H means what? In the accumulator complemented value is there. For that we are adding the 1. Thereby we will get the 2's complement. And where the result is again result is in the accumulator only. And after that what happens here? You see that the 2's complement value we are storing into the next memory location by incrementing. We are storing into the next memory location. After that incrementing memory location, we are storing the carry flag. So this is the program for the subtraction. I hope you understood this program. Now here this is the program to write to execute. Now this program in the exam, in the theory exam, if this program comes, then you can write program like this, and you can write what is the each and every instruction for what purpose you have to write it. But in the lab, while executing, here you can't show the label. Now here label we have shown, right? So instead of showing the label, this L1 is called the label. If the label, whatever the name you wanted to give, you can give, except the instructions which we are using in the microprocessor. So any name, any new alphabets you can use here to represent the label. So now here we have represented the label, but in the for lab to execute, so you can't give the label like this. Now here you have to specify the address location. How to specify the address location? Now it is jumping to here. And here what is the address location? 610F. So that you have to write here. Then only you can get the opcode, 3 opcodes. Now this is nothing but what? 3-byte instruction. So after within the instruction, you are specifying the 16-bit data means what? Address means what? It is a 3-byte instruction. You have to reserve the 3 memory locations. The first memory location is opcode. In the opcode sheet, you will get the opcode for the JNC address. For that, you will get the opcode. And after that, 2 locations are whatever the address you are specifying. Lower order address first you have to give. Next higher order address next you have to mention. If you write like this, then only you will generate the opcodes. Then you can execute the opcode. Now, how to write this and everything in detail, I will explain in the next lecture. Now, here I started with this 6100. This is the 2-byte instruction. Why? Because within the instruction, 8-bit data I have specified. This is the 2-byte instruction. That's why 2 memory locations are reserved for this instruction. Now, if see the LXI H,65. Now, within the instruction, 16-bit data is specified. So, this is the 3-byte instruction. First byte is for the opcode, and second, now here also first byte is for the opcode, and second byte is for the data which you have specified in the instruction. Now, here the first byte is the opcode, and second byte is for the data you have mentioned. Now, first you have to take the lower byte, and next you have to take the higher byte. Now, the remaining all are the, this is a single byte. No data is specified within the instruction. It's a single byte. This is also single byte, single byte, single byte, single. Now, here this is the 2-byte again. Move immediate data you have specified. So, one is the opcode, and another one is the data you have specified that you have to write. So, how to get the opcode sheet I will show in the next program. Okay, this is about the subtraction.